All right. So what's kind of nice is usually when you get into math notes, usually as you go, it gets harder, but actually this gets easier because now we're going to do the same thing that we just did with those trig ratios, but this time we're going to be on the unit circle. And so what's important to know about that is right here. And that our circle is going to have radius 1, which makes our life so much easier because we do not have to find the radius, aka the hypotenuse of the right triangle. We just know it's 1. So we're going to look at the unit circle. So everything that you see right here with this little guy pointing, xy is still that coordinate, remember, where the terminal side, which you can see in blue, so that points on the terminal side of the angle. I dropped a perpendicular down from that point. So theta, which is tucked under the terminal side and in between the x-axis, our opposite side is y, our adjacent is x, and this time our hypotenuse is 1. It's obviously r, but the radius is 1, it serves as a hypotenuse. So you'll notice I put these angle measures around the side just to kind of remind you of radians and degrees, and we're going to kind of fill in exactly what we did on the very front page of these notes, except for now it gets a little bit easier. So if you look at that picture and you want to think triangle wise, here would be our theta. And so sine would be y opposite over hypotenuse. Okay, so we know from the very beginning we said y, the sine of theta would be our y coordinate over the radius. Well, this case it's 1. So what's cool is on a unit circle, the sine of theta is just y. For cosine, it would be adjacent over the hypotenuse, which is 1. And in the front of the notes, we had x over the radius. But since it's 1, we just get x. And the tangent, same as before, is y over x. So what's really nifty on the unit circle is it says you should notice that sine, the sine of theta, is always just equal to the y value of your coordinate. The cosine is always going to be equal to the x value of your coordinates, ordered pair, and the tangent is the ratio of y to x, which in reality is just your sine of theta over your cosine of theta. And I'll write that down as y over x. So let's use these trig ratios in the first example. I think you'll catch on to this really quickly because we're only going to be dealing with some angles that I think you're comfortable with right now. So we're going to use the unit circle, and it says use the unit circle to evaluate the 6 trig functions of theta equals 90. So basically, right, what they want us to do is they want us to find the sine of theta. No, just kidding. We already know what theta is. Sorry. I meant to write the sine of 90 degrees. And then we want the cosine of 90, the tangent of 90, cosecant of 90. So you don't really need to write this down every time, but as I always say, I'm your teacher, and I feel like in your notes, we should have it done the proper way. So if you think about, we're still going to start with our initial ray, but you all know that when you rotate this angle about 90 degrees, lands on a quadrant. So this is called a quadrantal. I don't know if you've ever heard of that, but if you land on an axis. So notice we're located on the y-axis. Anytime you land on the axis, which has happened before, we said like positive y-axis, which is where we are, but that's called a quadrantal angle. So there's your theta right there. Now, what's important is that our coordinates, just like we've had in the other examples, it's 0, 1. So if we think about this like we did earlier, our x value is 0, our y value is 1, and we know our radius is 1 because it tells you we're on the unit circle. So now we can just go to town. So up here, since the sine is always the y value, well, it would be 1 over 1, so that's just 1. Now notice I can't drop a perpendicular because the point is on an axis. So that's why it's really important to know what we did in this box up above. The cosine of 90 degrees is going to be equal to your x coordinate, so that's 0, and the tangent would be your y value over your x. Well, that would be 1 divided by 0. Now, remember, dividing by 0 ain't going to work, so this is undefined. So I guarantee you right now, if you check on your calculator and try to type in the tangent of 90 degrees, you're going to get error or undefined, and that's why. Our cosecant would just be the reciprocal of sine, which we got 1, so the reciprocal of 1 is 1. Now, be careful here because a lot of people think, oh, the reciprocal of 0 is 0, and that's not true. So what might help you is when we did the cosine of 90, remember when you're doing cosine, if I look up here, we did x over 1. So this technically would be 0 over 1, which is 0. Well, what happens is when you do the reciprocal, it would be 1 over 0. So the secant of 90 is also undefined. And then to finish that off, the cotangent, well, the reciprocal of 1 over 0 is 0 over 1, and that's 0. Okay, so we are not using a calculator. No, no, no. Okay, so we're using our knowledge of these trig ratios. So now, if you will pause the video again, please pause. I know you won't, but please pause and try the 2 on your own on the next page. Okay, so I'm assuming you have these done now, the time it gives me to focus. So this time we are looking for an angle that lands on 270 degrees. So once again, we're going to rotate all the way around like we learned how to draw an angle in the very first chapter. And that point that's landing, right, is 0. I'm just going to write it bigger. 0, negative 1. Once again, this is called a quadrantal because it's in between quadrants. So we can't drop a perpendicular because if you do, you're right at the origin and you don't really have a radius. But we know the radius is 1. That's why it's special and we don't have to necessarily draw anything because it's landing on an axis. So remember, we have those ratios. So the sine is going to be your y value over the radius. Now I probably should have done this in the first, but remember your radius is 1. So I'm going to keep it like that just so that when you have a reciprocal, you don't freak out. So the cosecant would also be negative 1. The reciprocal of negative 1 is negative 1. For cosine, that was the y coordinate over the radius, and so that's 0. But when you do the reciprocal of cosine, that's going to give us undefined. Now remember, your theta in all these, we would substitute 270, but you don't need to rewrite it every time. The tangent is your y value over your x value. Well, the tangent of 270 degrees is also undefined, but the cotangent is 0 over negative 1, which is 0. So you can check all this with your calculator, but do not get in the habit of just typing it in. You're going to use your knowledge to find these like basic angle measures, okay? All right, last one. Negative 2 pi. Well, remember, negative 2 pi is equivalent to negative 360 degrees. So if we have our initial sine, we're going to go all the way around, right? Well, we're landing right here at the point 1, 0. How do I know it's 1, 0? Because remember, the radius of the circle is 1. And we're going to do it all over again. So our sine is our y coordinate over the radius, which is 0. This time, our reciprocal, 1 over 0, if it helps you to write it to understand, it's undefined. Our cosine is going to be the x coordinate over the radius. Well, that's 1, so therefore the reciprocal of 1 is 1. So the secant of negative 2 pi is 1. And then for tangent, it is your y coordinate over your x, and that is just 0. But remember, when you take the reciprocal, it's going to be undefined. All right, that's it. And so now you should be ready to roll for our next class. And we'll work on the assignment that goes along with this in class. All right, thanks everybody. See ya.